So this is chapter 8 of the AICE 2 book. This is a sign change rule we're going to look at to begin with. So just make this a little bit bigger. We're going to start with a definition. So if the function f of x is continuous, so basically you can draw it without picking your pen up off the graph. So also there's no asymptotes for this one, there's no vertical asymptotes. In a particular interval between p and q, and if we can find 2 points that have opposite signs, i.e. one that's positive and one that's negative, then what that tells you is that there is at least one root between p and q. So if it goes from positive to negative or vice versa, it must cross over the x-axis, which implies that there must be one root. Of course it could be more than one root as well. So finding roots of equations, let's do a very quick recap. So how do you find the roots of a linear equation? Well, you just set this one equal to 0. So if you set y equal to 0, 3 times 2 minus 6, so x equals 2 would be a root for that one. So linears are very easy to do. Oops. And if we do this for quadratics, then this will factor x plus 2, x plus 3. So we could find the answer for that one. This one doesn't factor so nicely, but we could use a quadratic formula. And then we get down to here, how do you find for a cubic equation? Well, this one would factor as well. You could take x as a common factor here. And then you could refactor as well. So that one there be roots at 0, -6, and -1. When we get to something like this though, it's not quite so obvious how we're going to do that. When we had it for the quadratic, we could use the quadratic formula. Not so easy when we get to cubic equations, so we're going to look at a method next on how to do that. Now before we do that question, we're going to look at this question here, and we're going to try a few points here and find out what actually happens. So if I was to plug 1.5 into this formula up here, what I would actually get is 1.75. Now if I was to plug 2.5 into this formula up here, and this time what I actually get is -1.25, and you can check both of those answers on your calculator. So what that tells you then is we have what's called a sign change here. This is positive and this is negative. Now if that happens between two values, and this is what our p and q is talking about, then it means that there must be a root between 1.5 and 2.5. Now if we actually look at this graph here and see what it actually looks like, then you can indeed see that there is a root between 1.5 and 2.5 at this point here. Also notice with this rule it says there is at least one root, so there could be more than one, but for this one we showed that there is at least one root. Once we've got that one root, then we can actually start to narrow it down a little bit more as to what the answer might actually be. So, slightly more complicated question this time. Find the roots of f of x equals -x cubed plus 12x minus 5. Now, quite difficult to begin with. One thing I'm going to do is I'm going to differentiate this, and the reason I'm going to differentiate it is I want to find out what the maximums and the minimums are. So if I differentiate this, set this equal to 0 and then solve, then -3x squared would equal -12, x squared would equal 4, so in other words x would equal plus or minus 2. If I substitute those two values back into this equation for x, I can also find out what the y values would be. Now if I can plot that on a graph, and I see that this is -x cubed, and I know the graph is pretty much going to go something like, perhaps didn't do a brilliant job at that one, but you can see for this one that certainly there's going to be 3 roots for this graph, and we can use that in a second. Now I found out from my sketch it looks like 3 is a possible root for this one, so I substituted 3 into my formula up here to see what I got. And I got 4. Then I plugged 4 into this formula. When I got that, I got -21. So what that tells you is, as there's a sign change here from positive to negative, there must be a root between 3 and 4. I guess I didn't draw this picture 100% accurately, but if we try a little bit more, we could try something like 3.2. And if I try 3.3, then also I have a sign change there as well. So actually you can keep narrowing down your answer as much as you want. So as long as you have a positive and a negative, you can say the root is between that. So certainly on the evidence of this, it would be between 3.2 and 3.3 would be one of your roots. Now what we just did there was very clever, but it's actually very time consuming to do that. So you're probably not going to be asked to do a little graph like we just did there with the differentiation finding the maximum and minimums, what you're probably going to be doing is just given 2 points and then asked, is there a sign change? And therefore you can continue and find out what the route is closer and closer. So let's take a look at something like that. And that's a good place to start, is by looking at the examples in the book. And then you should be able to do the first few questions for this by narrowing that process down to as many decimal places as appropriate. Now let's go ahead then and see if we can actually find the positive root of y equals x squared plus x minus 5 to 2 decimal places. Now I'm going to use a graphing calculator just to do some of the calculations to speed this process up a little bit. But if I'm finding the root, then what I'm actually doing is solving this equal to 0. So there's a little bit of guess and check on this, a little bit of trial and error. You have to sometimes get a little lucky. So first of all, I'm just going to try the value 1. So if I plug 1 into this formula, then I end up with -3. I'll try another whole number. Let me try 2 just to see what happens for this. And if I plug 2 into here, I get 1. Now straight away I can see that there's a sign change here, because this one's negative and this one's positive. So straight away I know that there is a root between those two numbers. So in other words, a root between 1 and 2. Now I'm going to go to 2 decimal places on this, so I'm going to need to go a little bit more accurate than that. So I could just go in the middle here, but I notice actually my answer is closer to 2 than it is to 1, because this number here is closer to 0 than this is. So actually for my first attempt here, I'm actually going to go with, I'm going to try about 1.8 and see what that gives me. Now 1.8 was actually a pretty good guess here. I got 0.04. So this is also positive and this is negative. So I could automatically say there's a root between 1 and 1.8. So I've narrowed it down a little bit more. Now as 1.8 was a little too big, I'm going to try 1.7, see if I can narrow it down still further. And this one turns out to be negative. So I can now say that there is a root between, to be a bit more accurate, there's a root between 1.7 and 1.8. So I'm doing pretty well so far. Now I've got to go to 2 decimal places. Now once again, I notice 1.8 is this answer is much closer to 0 than this one. So I want my next guess to be closer to 1.8 as well. So I'm going to go for 1.78. Just to see what that actually gives me. And it's another negative. So I could now say it's between 1.8 and 1.78. So I'm narrowing this down all the time as I go along. So as this one was too small, I'm going to go with 1.79. And I get 0.005. Now it looks like this is the closer one than this, so we might be prepared to say straight away 1.79 to 2 decimal places. But what we actually have to do is, once we've narrowed it down between 2 numbers to the correct degree of accuracy, we have to check the middle value as well. So we also have to check 1.785. Now if we plug in 1.785, you get negative 0.028. Now if we were continuing this to 3 decimal places, as this answer was too small, because it's between 1.785 and 1.79, I would now guess something like perhaps 1.786, 1.787, something like that. But the key part about that is, once you have that number, it's going to round up to this number. Now this step sort of looks unnecessary, because most of the time you can actually figure out which one it's going to be closer to, but not always. So you do need to check the midpoint of 2 values once you've narrowed it down between 2 numbers like that. A lot of students drop points by not doing that check, so make sure you're not one of them.